Yeah, hello everyone. Today we are going to discuss a few of the problems from rational functions. So the first question which is in front of you is, given that gx is 2 divided by x minus 2 minus 3 is the transformed function of fx is equals to 1 upon x. We have to describe the transformation that would need to be applied to the graph y equal to fx to obtain the graph of y equal to gx. Now here in this case 2 divided by x minus 2 minus 3, this is a transformed function of fx is equals to 1 upon x. Now if you observe it carefully, then first here we have a vertical stretch, because this fx is first converting in 2 divided by x kind of thing. So there is a vertical stretch by a factor of 2, okay, when the whole function is multiplied by some number, that okay. Then here we can see that x is changed to x minus 2. Now as x changed to x minus 2, we will say that there is a horizontal translation by 2 unit towards right. So there is a translation of 2 unit to the right. And finally this minus 3, it indicates that there is a vertical translation of 3 unit down. Okay, so fx is 1 upon x, this is the base function, and it can translate, it can transform to some other function. Okay, there could be vertical scaling, horizontal scaling, horizontal shift, vertical shift. Okay, so that we can identify. Okay, already we have done one chapter related to this, so from that information we can write all these transformations. This is the first part. Now the second part is complete the following. I have to identify domain. Now domain means what? Domain means all the possible values that x can take in this function gx. We have to do the problem for gx. Now denominator x minus 2 cannot be 0, otherwise it will become a non-defined function. So that means except x is equals to 2, because x minus 2 equal to 0 gives me x equal to 2. So except x equal to 2, for all other values of x, this function is completely defined. I can find out the value of gx. So my domain is all x where x is not equal to 2 and x belong to real number. Then range. Now what is range? Range is all possible values of this gx. Now here you can see that gx can take value as minus 3 when this 2 upon x minus 2 becomes 0. Now when this 2 upon x minus 2 becomes 0, when x become infinity, so again this is not possible. So as this is not possible, the value of gx cannot be equal to minus 3. There is another way. Okay, there is another way to solve. Here to find range, what we can do, we can express this x in terms of y. One way is that we will say that okay, is this part become 0? So no, for this to become 0, x should be infinity, and as this cannot become 0, y cannot become minus 3. So this is a logical way. Another way is that I will rearrange this equation in terms of x. So to rearrange in terms of x, what I done, I first moved this x minus 2 on the left side. So I rewrite this equation as x minus 2 divided by 2 is equals to 1 divided by y plus 3. So here what we have done, we have used invert endo, means we have interchanged numerator with denominator, and then I solve for x and I get the value of x as 2 divided by y plus 3 plus 2. So again here y equal to minus 3 is not possible. So either I will give answer based on uh, logic, or I will solve and find out which value y cannot take. So here denominator cannot be 0, therefore y cannot take value as minus 3. So as it cannot take value minus 3, rest all values it can take. So I will say that here range is all y except y equal to minus 3. Okay, then we have to find y intercept and x intercept. Now to find x and y intercept, okay, this is the given equation. Now to find y intercept, what we do, we put x is equals to 0. So as I put x is equals to 0, I get y is equals to 2 divided by minus 2 minus 3, and after simplification I will get y is equals to minus 4. So I will say that y intercept is y equal to minus 4, or simply I will say that it is a point 0 comma minus 4. That is my y intercept. Y intercept is the point, again this is the point where the curve cut y-axis, so wherever the curve cut y-axis, always its x coordinate is 0, therefore we use x equal to 0. And similarly to find x intercept, we put y equal to 0. So as I put y equal to 0, what I find that x after simplification, okay, you I hope you know how to simplify this. So here first I add 3 on both the sides, so that this minus 3 will vanish from that right hand side. Then after that, what I done, I do reciprocal, that means I interchange numerator and denominator. So 3 is nothing but 3 upon 1. So I have x minus 2 upon 2 will become 1 upon 3, and then I multiply 2 on both the sides. So here left hand side we have x minus 2 and right hand side is 2 upon 3. Then I added 2 on both the sides. So when I add 2 on both the sides, I get x is equals to 2 upon 3 plus 2. So 2 upon 3 plus 2, this 2 I can write as 6 upon 3. Why? Because for any addition, okay, the denominator should be same. So here denominator is 3. Here to make denominator 3, what I done, I multiplied and divide by 3. So 2 by 3 plus 6 by 3 is 8 by 3. Now you need not have to do all these calculations, because you can use calculator. So with the help of calculator you can directly find the value of x, which is x by 3. Simply if you are able to write equation, then simply you write equation as 0 is equals to 2 upon x minus 2 minus 3. Solve using the solve key on the calculator, you can find out the value of x, which is 8 divided by 3. So no need to perform all these calculations. You will get your x intercept as 8 divided by 3 comma 0. Now the next thing which we have to find out is equation of all asymptote. Now what is asymptote? Asymptote, we have here horizontal asymptote and vertical asymptote, means the curve, the line, okay, where the curve is parallel to y-axis is your vertical asymptote, and the line parallel to x-axis about which the curve is parallel to x-axis is your horizontal asymptote. Now how you decide for that? So again, for asymptotes, we can do this either by using the function which is given to us, or we can do this by using the graphical calculator. Now let me first explain how we can do this, okay, using the equation. So here in this equation, x cannot take value 2. As and when x will take value 2, the denominator will become 0, and I will have y is equals to infinity. So y is equals to infinity, that means I can say that when x is 2, that time the value on the curve is y value we will say that is infinity. So that means it is not going to touch that x is equals to 2 line, because we will not get an infinite point on the curve. So x is equals to 2 is your vertical asymptote. Now to identify the vertical asymptote, what is the key point? That denominator, okay, you put denominator 0, okay, and find out the value of x. That value of x will give you vertical asymptote. Either it will give you vertical asymptote, or it will give you point of discontinuity. Now what is point of discontinuity? I will explain as and when we will get a problem like that. Okay, so here for vertical asymptote we see that when x is equals to 2, okay, y tend to infinity, therefore we will say that x equal to 2 is a vertical asymptote. Now for horizontal asymptote, you can see that y will never be minus 3. Now y will never be minus 3 means y is equals to minus 3 line, it is never going to intersect. That means as x become large and large, the value of y will approach to minus 3, but it will never touch minus 3. So y equal to minus 3 will become horizontal asymptote. Y is equals to minus 3 will become horizontal asymptote. You can doubly make sure yourself that you are doing right by using the graphical calculator. Now using the graphical calculator and by adjusting your windows, okay, you can draw the graph. So here is the graph. Now on this graph you can see that this graph, okay, if I draw a line about x is equals to 2, then this graph is never going to touch that line, okay, either in upward direction or in downward direction. So I will say that x is equals to 2 is a vertical asymptote. Now similarly for horizontal asymptote, you can see that here is a line, horizontal line, at minus 1, minus 2, minus 3. At minus 3 there is a horizontal line which this graph is never going to touch. Okay, so I will say that the horizontal asymptote is y equal to minus 3. So either you give your answer using the graphical calculator, or you do this calculation as I have done over here and write all the answers. So if we summarize, we can say that here in this problem where gx is 2 divided by x minus 2 minus 3, so here this minus 3 is mostly gives you the horizontal asymptote y equal to minus 3. This denominator x minus 2, this generally gives you the vertical asymptote. So x is equals to 2 is your vertical asymptote. Now to get vertical asymptote, we will equate this x minus 2 always with 0. Okay, then to get a x intercept, we always put y 0 in this equation. Now what is y? The function gx value is y, so we put y 0, we get x intercept. If we are not getting x intercept, then we will say that there is no y intercept possible. Similarly, to get a x intercept, we put y 0, and to get y intercept we put x is equals to 0. Now in this case we can put x is equals to 0 and find out the y intercept. So here as discussed, we have find both x intercept and y intercept. Y intercept we got 0 comma minus 4, and x intercept we got 8 by 3 comma 0. On graph also you can identify all those values. Now you can see that this graph is cutting x axis, so this is your x intercept. Similarly this graph is cutting y axis also, so here you have y intercept also. So x intercept and y intercept I can identify from the graph also. So from the graph you can what different things you can find. From the graph you can find what is x intercept, what is y intercept. You can also find out the equation of asymptotes and domain and range. For that it is better that you see your equation. Okay, from equation you will be in better position to find out what is domain and range. Domain and range means what possible values can be taken along x-axis, and range is what possible values are taken along y-axis. Okay, so I hope you understand this problem, right? Okay, so I will see you next time with another problem. Thank you for being with me.